Hello everyone, welcome to the Flux Dev Meeting, 28th of January. Do we have any agenda items? Mateus, Max,
I can give updates about Helm.
well, Max,
Hey folks, I got nothing to add to the agenda.
okay. So before we jump into Helm, um, some Flux users have messaged me, and I think everybody should be aware that if you are deploying the now archived Kubernetes dashboard with Flux, starting today, that will no longer work because the Helm repository hosted on GitHub Actions, GitHub Pages is no longer accessible. I'm not sure if they intentionally deleted it or it's a side effect of archiving the repo. I have no clue, but you should be aware that all the Helm releases on all clusters having deploying Kube dashboard will fail starting today. You can still clone the repo, the Git repo locally. There is a chart directory in there. You can build a chart and push it to your own registry and recover from this. On the long run, you should definitely look into alternatives. Given that the project is archived, there is no one should be running this in Kubernetes anymore. There are like lots of alternatives. The recommended one, if you don't really do GitOps and you go with the UI and you modify all things in a cluster, it's probably Headlamp, which allows you to, create things, modify things, all of that, which Kube Dashboard also allowed. If you do GitOps and you want a dashboard in read-only mode, there are plenty of options for Flux as well. Flux operator comes with a nice UI that me, Mateus, and others are working on. I think you can also run Headlamp on the cluster and probably set it with a service account that's read-only. And there are other Flux UIs there as well. So lots of options, but you need to, move away from Kubernetes dashboard as soon as possible. That was the announcement. Mateus, can you say something about what's happening
Yeah,
with Helm?
sure. So, uh, the plans kind of shifted a lot since last night. We were waiting for a patch release in Helm 4.1 today, 4.1.1, that would fix a regression that we really need and also introduce some customization options for us to implement the reduce mean time to recovery feature. Um, but last night I found an unrelated problem in our CI that happens because the new default waiter of Helm, which is based on K status, is also based on watchers. And this has proven to be unreliable, their implementation so far. There's another issue there. I opened an issue about what I found last night, and there's another issue also related to the same part of the code due to watchers. And they just tagged me in this new issue. And I posted there that my my suggestion for Helm going forward would be to fix this by implementing a polling-based waiter with case status as well. Like case status can do both, right? We in Flux in customized controller for years we do polling with case status. Helm implemented watchers, and the watchers are getting stuck in several different situations. The major fix I was waiting for 4.1.1 was an issue of it getting stuck on failure in on terminal states in case status, like failed is a terminal state in case status, and it was like getting stuck on it into the timeout. That was the fix. So yeah, basically I told them this combo of case status plus watchers was not a good idea. Like this is two major changes in one for him 4 that is causing problems not only to Flux users but other people as well who are opening issues there. And we are now considering on our side replacing the case status waiter logic entirely, which is possible. We can by basically wrapping the Helm Kubernetes client. I have already tested the Go constructs required for this to work. So we can do this. And we are basically like shifting. So all this weight on Helm for the patches in 4.1.1 is not necessary anymore. We can like move independently and try to wrap the Kubernetes client and replace the waiter implementation altogether. So what this means for users in terms of API, in the Helm release API, we plan to allow you to choose if you want the legacy behavior of Helm 3 for waiting, or this new implementation that we are going to inject, which is based on case status, like Helm, but does not use watchers. It uses polling instead, which is more reliable. It will not miss states from the resources. Yep, that's it. I guess oh yeah, we also found a problem upgrading to controller runtime 0.23, which is already fixed. Basically, we had this undocumented behavior when you want to remediate a Helm release upgrade with an uninstall. So because of this bug from controller runtime, but actually from the upstream work queue, you would get a side effect like a requeue after returning max retries exceeded, right? Like in the Helm release state machine, you reach a maximum amount of retries, then the controller returns a terminal state error to controller runtime. Even though this code path was correct in our code, due to this bug in the work queue, you were getting another reconciliation event, which was triggering the install after the uninstall from the remediation. So we chose to keep this behavior because Helm controller is GA. So now, if your remediation for an upgrade is an uninstall, instead of like failing terminally at that point, you will get an install immediately after to like maintain this behavior that came from a bug that is now fixed in controller runtime. Yeah, that is merged.
Where are we affected by this anywhere else?
I didn't see
Like
any other tests
I
fail.
don't see it as a bug. I see it as this was a behavior. We used it, and now that behavior is gone. So from our perspective, this is not a bug.
Yeah, yeah.
This
I mean,
is
like my interpretation, reading the upgrade remediation docs in Flux website was that this install was not supposed to happen. That's not what the docs were communicating. But that happens. That happened for a long time, right?
yeah,
So
okay.
we
Whoever wrote the
And its
docs,
behavior and users also depend on it now. Yeah.
yes, yes, exactly. So users depend on it now. So basically, we made it an official behavior, a documented behavior. I added a line to the uninstall strategy in upgrade remediation saying that if that happens, you get an install immediately after. And that so your retries will now depend on install behavior, right? Because next time you're gonna do an install, whatever is configured there for remediation or not, you could have the other thing we shipped in Flux 2.7, right? Which is not
yeah,
which
with
is
retries, yeah.
yes, which is remediation less. So whatever is configured there is gonna kick in, basically. So this is documented now.
Yeah, so the fact that we used to get an object in the queue and now we don't can affect a bunch of stuff.
Yes, I was thinking the same thing. Like, this is what we saw in Helm controller. What if we were relying for something like relying on this behavior in another controller, right? I don't think so because the Helm controller is the only one that has a very complicated state machine. Like all the other compilers are like kind of pretty simple, like idempotent thing, like no retries and things like that. Like it's so
Now,
I
all
don't think
controllers do retries, but not through
through
not
the way Helm
preserving
controller
the.
does,
Yeah,
yeah,
I
like
know, I know.
returning the reconcile function and letting it like and requeuing, right? None of them requeue to do things like Helm controller.
No, all of them requeue.
Yeah, I mean, for example, in initialization when adding finalizers, right, or something like that. But but the problem here is a requeue when we return a terminal error, right? That's what was happening. Like a requeue was happening when our code was saying don't.
Oh, it's very
So
simple to search for this. Like,
yeah,
yeah, I can search for it.
yeah,
Yeah,
like
I
where
get it now. So it's the combination of requeue true or with a timer and terminal error on the same line. So I can write a regex and search all the repos.
yeah, but in Helm
Yeah.
controller, like there's two cases. When we return max retries, we return requeue false, requeue after zero, and the terminal error. And when the retries have not exceeded, then we return requeue true. That's what we do.
Also, requeue is deprecated and will be
Yep,
deleted from controller runtime. So we also need to migrate all the controllers
yep,
and
we
have
do.
some kind of helper function in our runtime to replace this.
Yep.
Well, yeah, going back to Helm and the whole thing around health checks in Helm before, like we have our own health check system running for 6 years now in customized control. Like virtually every single Flux user relies on that. It can take Helm, I don't know, months, 1 year before it gets to a case status which is stable and deals with all the edge cases we've been fixing in Flux around this. There are like many things that can go wrong. Uh, so yeah, I'm for swapping out Helm case status code with our own if we can, without duplicating any code. In theory, we should be able to expose helper functions in our server-side apply package that we can use in Helm controller to construct the waiter as Helm wants it, and we swap their whole code with ours. Some things that ended up in Helm before importing packages from Flux is, for example, a long time ago we wrote this job health check. So case status has this logic where it doesn't care if a job doesn't wait for a job, basically. If the job started, that's it. It's marked as healthy, which is not what 99% of people expect. You expect for the job to finish, and if the pod that was created by the job fails, you expect for the job to be marked as failed. And in Helm, jobs are tests, are hooks, are everywhere, right? So that's why Helm before imports the job custom status reader that we wrote in Flux. Now, if we swap out all the Helm waiter with our own, we need to make sure we enable our own job watcher in there by default, not as optional.
So
Uh,
our job waiter, not theirs, right?
yes.
Because they
Also,
do
they copied the code from us. They didn't import the package, and the Helm code around waiting for jobs does not match my latest improvements to Job Watcher. There are a bunch of things missing there.
yeah.
Maybe you should open a pull request and copy paste all of it. I don't know why they didn't import our code and choose to copy paste whatever.
Yeah. And
It's their decision, but
I'm looking at their copy paste right now, and it's not, there's a reference, and it's not even our case status. It's the upstream one, like from 29.4. I don't know how old is that. But yeah, like so diverges. I was wondering what to do about that.
if they didn't credit us, then we don't care. We don't have to update anything in Helm. We can just swap it to our own, and that's it.
Yeah.
Well,
Cool.
yeah, it's on them. We are also getting very close to deal with the cosine mess. Lee has made very good progress on getting source controller being able to verify both cosine V2 and V3 signatures. Cosine V3 has a very different type of signature, is a tough bundle. And in this migration, we also figure out there are various implications of cosine. With V3, for example, the CA has to be downloaded every 24 hours as a background job in source controller. And we are now looking at ways of doing this only if you use cosine in your sourcing. Like if you deploy Flux on a air gap cluster, we shouldn't, and you don't use cosine keyless because it's an air gap cluster, you shouldn't have access to a public recur endpoint, then we shouldn't be trying to set up all the certs because this will fail. We'll try to reach out cosine infrastructure, public infrastructure to download certs, to download the root CA and all these things. Everything will fail. And I'm not sure, like, why would we even try to do that and not it will result in a bunch of error logs, CPU usage, network usage, all that stuff. So we are trying to find a way to avoid this using singleton with a lazy loading. So basically the first ever OCI repo that has verification type cosine that will start the background refresher for the root CA. And then sequential reconciles will not touch it. It will see, okay, now it's running, leave it like that. The problem with what Wally found in Go Tough framework is that this procedure of getting the root CA is not thread safe. It's global, so you can't run it in parallel. Yeah, it is what it is. So we are doing our best trying to get cosine in Flux 2.8 because lots of people have to pin cosine to the older version to make it work with Flux, and we don't want to, keep this for long. I don't know. Maybe cosine will deprecate V2 and they'll have no CV patches for it, and that puts the whole Flux project into a awkward situation where we now import something that will never get patched and is full of CVs. And on top of all of that, cosine is supposed to be a security feature. So having CVs in a security package is definitely undesirable, let's say. Yeah, I think that was it with all the updates on the roadmap. Oh, there is another thing. So Mateus is talking with various other CNCF projects like Zot, Registry, Harbor, and so on to get passwordless authentication for this container registry in the same way we do now with workload identity for ECR, GAR, and ECR. And that will be really good to, not have to create image pool secrets for Flux to be able to download charts and artifacts. And my conclusion was that this cannot be just a simple feature. It needs an RFC because the current RFC we have, RFC 10, it's scoped to workload identity, right? It's all about clouds and so on. This not only is vendor neutral, no longer we are not going to use any cloud SDK for this. This is pure Kubernetes crypto work. And Mateus proposed to introduce a different field so we don't have this confusion of, the provider field should be for cloud providers, and this new field should be for this kind of identities. Yeah, can you say something about this, Mateus?
Yep, sure. So it's exactly what you said. Like, I think there's two main reasons for a new field. The thing about vendors versus standards, right? So we want to implement short-lived standards that support short-lived credentials, right? So, for example, OIDC and SPIFFE. And for OIDC, our approach has been leveraging the built-in OIDC from Kubernetes, where we don't have, like, users don't have to maintain the root of trust, which is the private key that signs the JOTs, right? That's a built-in feature from Kubernetes. So when we issue a service account token, we just do an API call to Kubernetes with the permission to create tokens for any service account in the cluster. That's what we introduced in 2.6, right? And we're going to use the same. The difference in implementation is that for cloud providers, we do a handshake. We call some APIs from the vendor to exchange the service account token for whatever form of credentials they have. And this varies a lot depending on the provider. Some are just a token, and like in Amazon, it's those triple value thing, which is access key, ID, secret access key, and session token. So none of that, like this feature is about using the service account token as is. We send it to the third-party service, like the container registry, like Zot and Harbor, and that service understands that token without need for any kind of handshake. So it's not only vendor neutral, it's also agnostic of the thing on the other side. So we implement the OIDC standard leveraging built-in Kubernetes OIDC for service account tokens. And the other side also implements the OIDC standard without knowing about Flux, right? I shipped this feature in Zot container registry this weekend. They merged my PR. And Harbor apparently already has it for a while. So I'm going to test my source controller PR with both registries. Literally, I want to see an OCI repo object using this credential for both registries. That's my goal for merging the feature.
So just to be clear, like Flux trusts the root of Kubernetes,
Yeah.
then whatever it's on the other side, whatever registry, whatever other service, shares the trust, right?
Yeah.
So it's not like we are not just sending a token in Ether and the other part will just verify the token integrity. We actually verify the token is signed by the shared trust, which is the Kubernetes root CA, right?
Public key. Yeah.
Yeah.
Through
So it's
OIDC, right? So
yeah, yeah.
the token has not only the token, but the configuration of the third-party service has to have the issuer URL. This issuer URL is also present on the JOT in the ISS claim. That's the URL the third-party service has to hit for getting the keys. And Kubernetes, by default, Kubernetes, this is the same thing as hitting the Kubernetes API server, but in practice, Kubernetes has features for swapping these URLs with binary flags in the API server. Today, we have docs in the Flux website showing how to use that in a safe way and how to rotate the private key of the API server in a safe way as well. So the right way to do this for a cluster, so let's say this feature can also be used, it doesn't have to be only on-prem. It can be used across cloud providers. You have an EKS cluster that wants to use Zot. Zot can trust the public URL of the OIDC issuer of the EKS cluster, which is public by default for years. So all the cloud
Right.
providers have.
Otherwise, kubectl will not work with EKS, right? It's the same um
No, I
or
mean, like the API server can still be private in a network sense, but the issuer is always public. The issuer is a customized URL in the Kube API server through a flag, right?
Mhm.
So that's what the cloud vendors do. They use this binary flag from Kubernetes to swap the URL, and instead of
To their
using,
own identity.
yeah,
Okay.
to their own public URL, right? It's like HTTPS EKS OIDC dot Amazon.com or something, with an ID of the cluster. So it's a public URL that the vendor exposes, regardless if the API server is private or not. So that's what they do. And on-prem, you should do a similar thing. On-prem, I I assume you know your way through managing the API server. So whatever distribution you use, whatever tools you use, the right and secure thing to do would be doing the same thing, swapping this URL. We have docs for that. That's what on-prem users should do.
So the URL should point to the WebKey set, right? The JSON WebKey set.
Yeah, it's actually in practice it's two URLs. You have one binary flag for each. So one is the issuer URL, then the OIDC libraries out there, for example, both Zot and Harbor are in Go. They both use the CoreOS OIDC library. That library gets that URL, appends /.wellknown/ OpenID configuration, hits that URL, gets a JSON. That JSON has another URL for the WKS
Yeah.
URL. So it's a second URL. You hit that,
I
and
mean, that's basic OIDC discovery. All languages have
OIDC
package
discovery
the cool, cool,
101
cool.
here. Yeah.
Cool.
Yeah.
What if I want to use, so let's say I have a Kubernetes, I have two Kubernetes clusters, not cloud, on-prem. Maybe I'm running in
Mhm.
my home lab. Um, on I want to dedicate a cluster for, I don't know, my home lab infra, and there, for example, in my case, I have a Zot container registry which is exposed to tailnet inside my network. Now I'll have another Kubernetes cluster where I will deploy Flux, and I want to create an OCI repo that should connect to this other cluster where Zot is, without having to either set Zot on public mode, which I could do because it's my private network, but let's say I want to secure it and I don't want anyone in my network to be able to pull things. I want for Flux on this other cluster to authenticate to Zot using the cluster where Flux is running as the authority. What that implies for Zot on the infra cluster to be able to call an endpoint from the Flux cluster to get the key set.
So you have two alternatives here. If you are okay for the Zot container registry to hit the API server of the Flux cluster, you don't need to do anything. It's the easy case. You just configure Zot with the URL, the API server URL, because it
And
matches
the
the
other one.
OIDC. Yeah, when you vanilla Kubernetes like kind create cluster, when you do that, the issuer URL matches the API server URL. It's the same URL.
Yeah,
So if the easy case inside your on-prem network, if you're okay with the container registry hitting the API server where Flux is running, of the cluster where Flux is running directly, that's the easy case. You don't do anything. You just use it. You just use the feature. You
yeah.
just configure Flux and you just configure Zot
Well,
or
and
whatever
network
registry.
access because
Network, yeah. So the container registry through the network will hit the API server of the cluster where Flux is running. That's the easy case. The more secure case, the advanced secure case is you configure the cluster where Flux is running with the binary flags in the API server to swap the issuer URL and the JWKS URL. You serve those two endpoints somewhere where you consider fine for the container registry to hit, right? For example, you could like this is private public keys, right? Nothing private here. So you could like host this in S3, GCS, whatever. Like you like make this tuning in the API server with the binary flags. You host the content of what the API server would serve there somewhere else. And you and your tokens will point the container registry to this place. The URL of the issuer, like when you do this, when you configure a custom issuer URL in the API server through the binary flag, the ISS claim of the JOT issued by Kubernetes will now have this URL. And the same URL you have to configure in the ZOT configuration, for example. In the ZOT configuration, you have issuer. You put this new URL there, which would otherwise be the API server URL in the easy case.
Okay, let me ask. I really don't want to generate my own keys and host them outside the Python. That's out of the question.
You don't need to
How
generate the
about,
keys. You to
what do you
host
mean?
outside, you just like you just the Kubernetes will still manage the keys. You just have to get them from the API server and host the content that you got somewhere else. That doesn't mean generating the keys yourself.
Oh, okay, I understand now what you're saying. And Kubernetes does not rotate these keys?
I don't think so. Last time I checked the Kubernetes code, it was a very static thing. It's like comes from these binary flags, and I don't see any automatic rotation logic in the Kubernetes code for that.
But the challenge with this is like, okay, if I have to cluster, it's easy. What if I have 500 Flux clusters and one cluster is the registry? Now the registry has to what? Trust 500 clusters, connect to 500 APIs. It's Can you
So
even tell Zot to connect to 500?
in this case, I think the best thing to do would be fine tune like this. In this case, you have to manage the keys. You have to own the PKI management because Kubernetes also allows you to specify the key. You
Right.
can specify all things. You can specify the issuer URL, you can specify the JWKS URL, and you can specify the private key as well. And in so what you do is you have a private key. So there's security implications in sharing this private key for all your
Of course.
clusters, right? Like
You
you
probably don't
would
want to do that. Yeah. Yeah,
all the
you get
it's
into
a trade-off.
PKI discussions, which I'm not
Yeah.
prepared to
Like
do. Like
we're
that's
literally
that's a
we're
different
literally
thing. Yeah.
leveraging the PKI of the cluster for this feature, right? So either you register 500 URLs in Zot, or you share one private key with all clusters to register only one, and then all the source account tokens from all your clusters will come from the same private key. That key is stolen, your clusters are hacked, right?
Yeah.
So yeah,
Yeah.
and that's why, for example, we that's what leads us to the next step in short-lived credentials for Flux, which is spoofing, right? Uh, we have so far done what all the cloud providers do to offer you a good UX in terms of workload identity. All the cloud providers do that. All their workload identity features are based on the OIDC built-in feature from Kubernetes on using this private key, right? All those
Mm.
features. So we have just replicated that everywhere. Like we have done what they do, what cloud providers do. Next step is SPIFFE, right? Like SPIFFE is essentially a standard for how do you express an identity. It works for JOTs, it works for X509 client certificates, right? And it also relies on OIDC. Big news, right? Like Spiffy Jot is also IDC and also requires a private key. So, but in this case, we have alternatives. The one I described in my issue is we have one binary flag in all the Flux controllers that would benefit from this feature, like minus a Spiffy private, Spiffy secret key, secret name, Spiffy secret name. The controller would watch this secret to have this key, and this mirrors the the built-in OIDC model of Kubernetes, which is one key for everything, right? One key that issues all the service account tokens in the cluster. If we mirror that model, we would have this binary flag in the Flux controllers. Another alternative that I have been thinking in the last couple of days is we could also put we could also use cert secret ref here or an object level field, right? Like
Mhm.
you specify the private key to issue the
Yeah,
the
so
spiffy
we
jot in the
yeah,
object.
so with Spiffy, I think there are two discussions here. Like definitely for someone which does hard multi-tenancy with Flux, where you have a tenant per cluster, those users will not want to copy the Spiffy private key in all those namespaces. They will want to put the private key in the Flux system namespace. This mirrors in a way how Flux does secret decryption by Max. So
Yes.
these mirrors in a way SOPs and how we integrate it. Like with SOPs for H keys, right? We by default everyone can say here is my private key in my namespace in the custom resource in a Flux customization. But if you are running hard multi-tenancy, you don't want to make all your tenants have a copy there. Add the secret ref for the age private key in all the customizations. What we have is this binary flag in customized controller where you say, hey, here is the secret in Flux system namespace. It can't be in any other namespace, has to be next to customized controller, and customized controller starts a watcher. No, it doesn't start a watcher. Every
Yeah,
time it
yeah,
needs to do an operation, it will read, bypasses the cache, reads the secret from etcd, which ensures that if you rotate the encryption
it's
key,
fresh.
will always get the fresh one, right? So we could, in theory, have the same approach to SPIFFY identities where we have it as a binary flag, is tied to the Flux system namespace, works great for hard multi-tenancy. When you do multi-tenancy on clusters where namespaces are dedicated tenants, I don't think we should assume that all these tenants will want to use the same identity. What if a tenant connects to a registry
Oh,
outside the cluster,
but
which
but having a shared private key in the controller specified through a binary flag does not mean sharing the identities because we are going to issue different literally different IDs in the short-lived credentials for each Flux object. So at the end of the day, even if you have one private key in source controller, like uh the jot or the client cert that we're going to issue will have uh kind, name, and namespace. So it's a different ID. Like you can
I
on
get it. Wait. I totally get that. Of course, it will be every object will have its own identity. The claims will contain the object, maybe Kubernetes UID, maybe, of course, name and namespace and kind.
yep,
But beyond that,
yeah,
you'll still share the trust root
yes.
through all the tenants. And from a Flux perspective, that's not a problem. Where I see the problem is on the other side, on the registry, because the registry will have to trust this shared key. Now, what if a tenant has a dedicated registry, another tenant has a dedicated registry, and they are like not in the same organization?
It's just the
Don't they
private
need
key,
that private key?
the public key. You in Spiffy, you only need public keys to verify.
Right. So it will
Either
be the same public key of the
same public
cluster
key.
everywhere. So the public key is no longer exactly. So the public key is no longer the public key is not an attribute of a tenant. I don't have as a tenant in the cluster. I don't have my own private public key. Is coming from Flux, which is shared across the whole cluster. So every single
Yeah,
tenant.
which is similar to built-in OIDC, right? It's
Right.
same idea.
Now I see what you are saying. Yeah.
Yeah.
So
So
like the
that's why
Kubernetes one. You're right. When it's one per
yeah,
cluster, we are going to emulate this. Okay, if you
yes.
don't want to use the Kubernetes trust root, you can have a trust root in Flux itself using SPIFFE, but it will still be one per cluster to mirror the
Kubernetes model.
Kubernetes model.
Yes.
Okay.
So that's my ideal implementation because it mirrors the Kubernetes model. But I started thinking about having extracting the key from a field in the object. But think about it. Is this still secretless authentication? Like the 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 idea of secretless is that you don't specify a secret in the object and you get an identity, right? So we're basic imagine that we do object level private key for SPIFFE. We are copying GitHub app. GitHub app
Right.
is exactly that. It's like
Yeah.
we're copying GitHub app. So I'm starting to think that
Right. We are not
uh
doing it. I mean, yeah, you don't create an image pool secret. Now you create yet again a secret with a different
yes,
crypto material, but in the end,
it's a
uh,
secret. Like you
it's
it's like
yeah.
GitHub app. GitHub, what's the benefit of GitHub app? GitHub app is you don't send through the wire the secret. You send a short-lived credential, but it is still generated from a secret that you specify in the object. So
Yeah, I mean,
it's just that, right?
GitHub app has a major advantage is that a GitHub app, the identity of a GitHub app is not linked to one of your org members, is linked to the org itself, right?
Yeah.
And
There's
that's
that.
the only reason
Yeah,
everybody should be using GitHub apps and not personal access tokens. But
yeah,
the difference between a personal access token and a GitHub app from a crypto material is not that big. Okay,
yeah.
if you have man in the middle in the network, GitHub app is way better, right? Because that key
Because the token is
expires,
short-lived. Yeah,
is short-lived. A personal access token is not that, lives for days, months, whatever,
years.
right? So I don't think you can have more than 1 year
Oh,
for the
true,
personal access, right? So it's
true.
1 year. Anyway,
And
if someone sits in the network and can sniff anything, it's way worse to get a PAT instead of a ephemeral token issued by the GitHub app. So GitHub app has like this major advantage around this is an org identity, not a person, and also the fact that is more resistant to man-in-the-middle attacks over the network. So, but I agree with you. I think we should, if we go with SPIFFE, we can anytime do
the
uh
field.
the field.
Yeah.
In the RFC, I would say in RFC for this future, have a use case for SPIFFE. No code there, just describe what we talked today. Like maybe why is this use case? Maybe you don't want to reuse the Kubernetes trust, the root trust of Kubernetes. You want to have a different crypto material for Flux
Maybe
itself.
it's much easier to automate the rotation of
Of
a
course.
key in the Flux controllers than in the API server, right?
And you don't share the same trust root, right? It's different. You
Yeah.
can have Spire, right? Is the implementation. You can have it externally and so on. So it's like you can build your own PKI infra outside of Kubernetes, reuse it in Flux through our SPIF integration, which is very different from relying 100% on Kubernetes PKI. So
Yeah.
I think it's a compelling use case. It should be there in the RFC. We shouldn't promise any deadlines around anything. I mean, it's an RFC, it doesn't promise stuff.
Yeah.
We
For
can do
2.8, I just want
the
to get the source account token in and
yeah.
leave the rest for later.
If it works with something, if if today
Yeah.
it doesn't work with Zot, it doesn't work with Harbor, there is no rush to deliver this in 2.8 because you can't use it with
Yeah.
anything else. So it's like
Yeah.
I'm not for shipping a future which is unusable, right?
Yeah.
Anyway,
In
having the
Zot, it is
RFC,
definitely in Zot, just to give some updates about Zot specifically. I shipped the feature in Zot, right? And I made sure. So they asked me for this end-to-end test in a shell script, like 1,000 lines of shell for this test. And I made it very thorough using Crane. And our code
Flux, yeah, of course.
is basically Crane, right? So I made sure that the test there uses the same credential field that we are going to use in Flux. So it is
Yes, Crane,
definitely
the
going to,
CLI, and Flux have the same Go
yes,
package behind it. Yeah.
yes. So it will definitely
So
work for Zot. I will test it anyway, end to end with source controller or CI repo, and do the same
bugging.
for Harbor.
Oh, another thing. Um, having it in source controller is not enough.
Yeah,
If
yeah,
we have capability of pulling, we should have the capability of pushing, right? So the Flux CLI, all the artifacts commands, push, get,
right,
list, everything needs
right.
to work with this new type of authentication because our
Yes,
users always do both, right? In CI, they use Flux, the CLI, to push artifacts, source controller pulls it. So even if of course, we ship something first in source controller because it's way more complicated to implement it there, but it's not feature complete unless the CLI
yeah,
also works in the same way.
yeah,
Like we have like Flux push works with Azure, a workload
yeah. You can
identity,
have minus
Google,
provider. Yeah.
right?
Yeah. Yes.
So
I
we
added the
need to
flag.
mirror that.
I already have a branch for Flux CLI with minus credential.
I'm not talking
And
about code, man. RFC. Like you shouldn't be writing
yeah,
code.
yeah,
You
yeah.
should be writing the RFC. So the RFC has to propose what flag should be added to the CLI and how that can be used.
Right, right. But what I want to say here is that the what we're going to implement here is a way for Flux to authenticate. So inside the cluster, let's say in the first iteration where we implement service account token only and not SPIFFE, we're going to use a service account token from the cluster. For Flux push to have a similar thing, uh, it would have to be running inside a cluster, right? Like if I mirror source account token for Flux CLI, the Flux CLI has to run inside Kubernetes, so it can have a service account token. Or it can, let's say, if it's running in GitHub, it can use the OIDC token from GitHub Actions. And it will work because at the end of the day, it's OIDC. So it's if the container registry understands OIDC, it will work with Kubernetes Service Account tokens, or it will work also with GitHub Actions OIDC token. So this this matching with the CLI makes sense if, like, from our perspective, we're implementing service account tokens, right? So it don't make sense if the CI is running inside the cluster. So if yeah, if we one thing we could do, for example, like we can definitely do that. I already
Wait a
did
second.
that.
Wait a second. So when we use workload identity, we tell people, hey, if you want for the CLI to be passwordless, you should spin up the job that runs Flux push. Should run in your cloud infra on a VM that has the identity set up in a way that's allowed to do the operation, right?
Yeah.
So this is the major constraint. We are not talking about anything beyond this, right? We should assume a similar constraint for this vendor neutral authentication. Like you should spin up the job in your Kubernetes cluster, and the CLI will be able to take the identity from there. If you spin up the job on your laptop, which is not on your cluster, it can't reach the cluster API, then don't expect things to magically work, right? So we are going to ship this in the CLI with the same constraints we have for source control, like it needs to be where it needs to be, right? And there are many people running GitHub Actions in Kubernetes through the self-hosted runner as a pod. So if you have the, I don't know, GitHub Action Operator or however it's called, or you have the GitLab runner that also works in a pod and is there in the cluster, I think you should be able to use the Flux CLI without setting an image pull secret.
Yeah. So there's a few different ways to implement that. Like for example, if you run the Flux CLI in a pod where you use the projected volume API for projecting a service account token. In this API, you can specify the audience. The most important thing for this feature will be is for you to be able to specify an audience. So one way is that, like you can use the projected volume API to mount a source account token with a custom audience. And then you point like the CLI has a flag that points to that file. Another way is that pod source account has permission to create a source account token for itself, only for its own source account. And the Flux CLI code, instead of reading a file from the file system, it can use a Kubernetes client to issue a token for itself with a custom audience. If the second code can be leveraged locally, you can in your machine through your kubeconfig that has permission to issue a service account token. You can use that. Like, so if you build into the Flux CLI this code, you can do that. Another thing we can do in the Flux CLI is native integration with GitHub OIDC tokens that many tools have. Like in GitHub OIDC, like doing like users writing GitHub actions to integrate the Flux CLI with the GitHub OIDC will look messy. Like you have to hit a URL that is in an environment variable in the GitHub action and blah 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 and a bunch of things. So another thing we could build that as a future work that I can like just list in the RFC is native integration with GitHub actions, for example. Like you just do minus GitHub or something, and boom,
Yeah.
you use the OIDC token with the audience that you have registered in the container registry.
We have that for Flux push. So the Flux push has credentials flag where you pass the ephemeral GitHub token provisioned by workloads, the workflow. So this is already solved and works really nice
No.
because you say
Not
you set the
solved.
permission. You set the permission in a workflow where you say write to the package, write package. GitHub will provision the default GitHub token inside the runner with that permission set. Then at Flux push, you pass the token to minus creds and it works. This is how everybody uses it.
Yeah. But this is for GHCR, right? What we're talking
Yes.
about here is GitHub pushing to Zot or something. In that case, what you want is not the ephemeral GitHub token from GitHub
Right.
Actions. It's an OIDC token, which is not by default issued when you have a GitHub action running. Everything that integrates with that, like for example, take any cloud provider action to log in into the cloud provider via OIDC. What that action does is do this dance with the environment to issue an OIDC token with a custom audience that the cloud provider will understand. That's what I'm talking about here. Like that's what
Like
we would have to do.
the AWS login action that you have
Exactly.
to use
Exactly.
before you can do Flux push. Before you do Docker login for Flux push to work to ECR, you have to do AWS login. And AWS
Exactly.
login does all the dance with, oh, here is the token, sign it, add the audience, put it in the environment. Then Docker login just creates the pull secret with that signed jot, and that's how the magic works, right?
Exactly.
Okay,
That's what I'm talking about.
I really need to go. We are over time. So to conclude about the RFC, we should capture SPIFFE even if it's not something that we are going to deliver right away. We should definitely mention the Flux CLI there in the RFC as something which is in scope at some point. And yeah, go into details, explain why we chose a different field and we are not overloading the provider. These are cloud providers, this is something else, it's vendor neutral and so on. We don't want to mix both. And also, please mention the fact that we are not going to support a mix of cloud providers and this type of authentication. You can only set provider generic. If you set provider AWS, you can't give us service account, right? That will never work. If you say AWS, you are going to do workload identity, the AWS style, and not mix SPIFFE with AWS ADC and have some craziness out of it, right? It's like you need to choose your path after this gets implemented. Okay, thank you very much.
Cool.
I really need to run out. See you all next week.
Thanks,
See you
guys.
next week. Bye.